The whole point is that the whole mass is crunching in, and there will be a star. There will be a star born. Hello, ladies, and welcome back to Universe Sandbox 2. 20 Earth languages and 12 Jovian moons. Jovian means Jupiter, by the way. It's Jupiterian because I guess Jovian is easier to say than Jupiterian. Jovian system. Jovian system, Jupiter system. It's the same thing. Things have been added to Universe Sandbox. This is Alpha 21.1. This isn't even beta yet. We're still on Alpha in Universe Sandbox. And it's a simulation about the history of Jupiter's moons. And also, Universe Sandbox now supports 20 plus languages. Do we have French? Francais. Here we go. Switch into French. Contour and Francais. French. Jours per second. Jours means time. No, jours is hours. Hours per second. I can do this. I can proceed in French. In 2017, a team of astronomers discovered a dozen additional small moons orbiting Jupiter, bringing a total to 79. Astronomers finally announced the discovery of these 10 now confirmed moons in 2018. One of these moons, called Veiltudo sounds pretty good. Like Justin Trudeau, like Veiltudo, Justin Veiltudo. It travels around Jupiter in a counterclockwise direction known as a prograde orbit, even though the group of moons closest to Justin Trudeau orbit is in a clockwise or retrograde direction. This increases the likelihood that Veiltudo may someday collide with one of the other small moons. Veiltudo has a particularly interesting orbit, and we can probably make it much better and forcibly collide this into something. Oh, that's the moon? It's a rock. That's the moon. What's the mass of you? 10 to the 13 kilograms, still pretty big. Closest thing we can compare it to is the moon. So it's like a 1 billionth or trillionth of a moon. It's suggesting that this guy, Veiltudo, will collide because it's in a prograde orbit rather than retrograde. I can see that. So these guys are going this way, but this guy's going this way. So if there is a collision, it will be extremely violent. This is super far from Jupiter. Jupiter's way out here, and Jupiter's a pretty big planet. And just from this perspective, just really zooming in here, Jupiter looks pretty tiny, like probably smaller than our sun. Like when you're looking at it, it probably looks smaller in the sky on this thing, if you can even stay on this thing. It's so small, the gravity is probably so light. Simulation can't run any faster than 1 day per second because apparently I have a computer from 1996. We're gonna pause right here because we have two orbits about to intersect. So we're gonna play God a little bit, and we're gonna try and bump things a little bit closer. I'm gonna get my edit button here, and I might just bring up Mr. Justin Trudeau here. Let's see if I can do this correctly. So I'm gonna get a nice top-down view here, and and I'm hoping, I'm pretty sure when I'm using this edit button, I mean, everything's gonna look so wonky here. I'm basically just dragging it over and like, oh, magically this orbit has changed course and it's conveniently right in front of another one of these moons. But we have to take into account, okay, so it's currently flying this way. I need this guy to approach from this side of the other moon. I keep wanting to call them rocks. I hardly consider these things to be moons. I mean, you just look at them. They are rocks. They are very, very big rocks in space. But it's a moon, technically, since it's an artificial satellite. It's orbiting it. I think any piece of rock technically orbiting a planet can be called a moon, but call it a satellite or a rock. We probably have other rocks orbiting us too that are a pebble. Imagine that, Earth having 2 moons and we never discovered it. Well, that'd be news that the world really needs to hear. This looks like everything will just be fine. Let's go by the minutes per second. How about this? Or maybe seconds per second, since this is so close. All right, so 12 seconds per second. Oh, that was very fast. And that is what happens when suddenly that moon crashes into another moon, oncoming traffic. So let's just pretend this happened naturally, because I don't know when this would happen naturally, millions of years in the future. These guys eventually lined up, and now things are happening. And whatever object this is, I think this is the new combined object. I think the name for the object that we crashed into overtook that name. So now things are drifting off into space. What is the orbit for this like? What is going to change? Let's speed this up as fast as possible. Will it be completely catapulted from the Jovian system? And it looks like it is. It looks like it's just going way out because these things are tiny. And there probably wasn't a whole lot of gravity pulling it in anyway. So it may have just completely disorbited. I'm spewing out a lot of nonsense now, but bear with me. Things are going to work out. But I'm already noticing a little bit of a curve here. So let's see if this velocity is going down. If the velocity is going down, it's confirmed. It's coming back. Motion. Velocity speed is increasing. But is it increasing in the other direction? Are you... Oh, yeah! Oh, yeah. All right, so there's nothing you can prove from this. This is not any kind of realistic experiment. I dragged this with my edit tool and forcibly placed it right in front of the nearest moon possible. Does it hold weight? If the velocity stayed the same and you just pretended that time went by and the orbits lined up, that's kind of cool. It knocked this guy out of its orbit and then briefly catapulted it out of the system, but Jupiter's orbit is or gravitational pull is way too strong, and pulled it right back in, and now it is giving it this crazy, crazy, crazy eccentric orbit. Now, the big question is, what's gonna happen when this guy gets close to Jupiter? Will he get sucked up by Jupiter? Will he collide with one of the many other moons that are in Jupiter's inner orbit? Oh, I wonder if I should play God again and intervene and have this guy collide. No, if this guy collided with like Europa or something, nothing would happen, I bet. Okay, slow it down, slow it down, slow it down, slow it down, and it just flung right by Jupiter. That just skid Jupiter. If not, went right through the atmosphere. So this little guy got this close with that stupid experiment that we did. All I did was just collide Justin Trudeau into this guy, and suddenly it's here. It went maybe not millions of miles away, but probably at least a million miles away. Jupiter's big, and that was far out. We managed to get this guy here with a little collision. That's cool. That actually might have catapulted it out of the system. So yeah, that is a hyperbolic orbit, I would say. The previous update that I was never actually able to recreate, but we managed to get a gravity assist like that, so yay me, I'm gonna pat myself on the back for that one for sciencing stuff I don't really know much about. More tools. There's this nice button called Halt All Velocities. Does that mean everyone is just going to crash into Jupiter? I think so. And we're gonna see if Jupiter can take the bombardment of its entire system and fuse everything together. So let's speed this up. Boom, right there. Okay, we're seeing a lot of dots. So it's Jupiter's moons versus Jupiter. Call it the Jupiter experiment. Although everything is getting all messed up in there. Look at that. That's actually cool. It's like we're creating like this big hurricane. That's straight out of The Day After Tomorrow, actually. You know that scene from The Day After Tomorrow where I had the 3 hurricanes on there? It's dwarfing the big red spot. Now we're just calling it the many big black spots. Actually, they're already disappearing. Oh, there we go. The big gaping brown spot. Oh, the second big gaping brown spot. Have the big ones even come in yet? Actually, I think all of the big ones have crashed into there. That must have been like Titan, Europa, and ukulele. All right, Jupiter. Looks like it was attacked by a machine gun, and we have one stray moon out there, and all the moons are gone. Those are Jupiter's moons. Every single one of these black spots was an attack on Jupiter because the moons decided to say screw it and launch themselves right into the planet. I really want to know what it would take to turn Jupiter into a star. Like, how many of these guys would you need? Launch Titan into Jupiter. Many, many, many Titans. Because a gas giant, call it a pre-star. How many would it take to form a star? You have to keep adding mass because Jupiter is not massive enough, but it could get massive enough to become a star. And as you can see, it's glowing, 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 and glowing. So we have a lot of Titans coming in, and they're all going to crash right into Jupiter. Okay. More and more and more of these guys. Eventually, this will become a star, I'm pretty sure. not been counting, and I don't know why. But you can get a good sense that it's probably in the hundreds. Let's see. So this is the mass of 1.01 Jupiter. Well, let's take a look here of, let's compare Jupiter's mass to the mass of the sun. So we have 0.01 Jupiters that we have added. It has even gotten close to doubling. That's the mass of the sun, but that's not the smallest mass that it takes to form a star. But maybe we should collide a lot more masses together until we get a star. Let's go in terms of Jupiters. Let's fire a second Jupiter at Jupiter so then we can have a double Jupiter. And then something like that happens, and I'm sure this will start glowing, right? It's just going to become a massive, massive, massive gas giant. And actually, for some reason, it's only the mass of 1.5 Jupiters. It can't... I guess that's like all the gas that's just floating around, and maybe some more mass will gain. But it did lose a considerable amount of mass when something the size of itself just crashed into it. Let's do it again. And we're probably going to have the same deal. Now we're at the mass of 1.22 Jupiters. So we can't even get it to collect its own mass. Now it's 1.33 Jupiters. Can we do it again? Let's try and shoot it towards all of this gas. And so maybe all of this will collect. No, let's shoot it back. Shoot it back. Shoot it back. Okay, now we have 3. Okay, maybe everything will actually collect. We're still at 1.9 Jupiters here. All right, now we're at 2 Jupiters. Good. All right, we managed to get that going. Okay, do that very quickly. And then do this very quickly. Absorb everything. 2.73 Jupiters. Okay. 1.2 Jupiters. All right. Just stay. Just stay. We just need to keep collecting it all. Now it's the mass of 7 Jupiters. Okay, will we form a star by firing many, many Jupiters? 2.8 Jupiters. We can't get the gas to stay together. Wait, it's getting white now. 1.8. Nope. There's just gas everywhere right now. Okay, that's going there. That's going there. This guy must be a lot. Actually, this is the mass of 6 Jupiters. Okay, it can get better. Let's slow this down. Okay, do that. We've lost all of our sound for some reason. Now it's the mass of 1 Jupiter. We completely lost all that gas now. We can't get it to hold together. I'm just going to abandon this guy. I'm going to go over this Jupiter over here because it seems this is only the mass of 1 Jupiter, and it is extremely hot. This looks like it is ready to become a star. What if we fire Uranus into Jupiter? Maybe something a little smaller. Now it's only 202 Earths, 148 Earths. It's just losing mass whenever I do that. We're done with the Jupiter experiment. Jupiter will become a star, but we have to make sure we don't lose any of the gas. So we have to make sure that Jupiters, when these Jupiters reach Jupiter, the gas that expands outward, we have to make sure all the gas that gets released from Jupiter gets collected back into Jupiter. And I think the best way to go about it is to make sure Jupiter is traveling in the direction of the gas that is spewing out. But that is violating Newton's third law. I don't know. I feel it's violating Newton's third law. We're violating it somewhere. We have to break Newton's third law. We're just going to get a bunch of Jupiters in the same radius by spinning around Jupiter. They're all going to crash into one centralized location. And then a star is going to be born with all of these Jupiters crashing into Jupiter. Everything is rushing towards the center. The gravitational pull will be too much for the gas to escape. It's impossible for it to go everywhere. So the only acceptable scenario or result from this scenario is a star. I hope. It's the only way I can see it in my mind. Or maybe it'll just supernova right off the bat. But all of these are going right towards the center, and we're going to go extremely slow because we want to enjoy this. The big crunch is coming in, and it's okay if some of these guys start crashing into each other before they reach the actual Jupiter. The whole point is that the whole mass is crunching in, and there will be a star. There will be a star born. That actually looks kind of cool. Not gonna lie. So much gas congregated in the center. What will be the final result? Brightness! It will be born! I'm seeing less Jupiter names. I'm not seeing gas spewing everywhere. Did I just fire another one? I think I just fired another one, but that's okay. Why is this the mass of 68 Earths? How many Why are you only the mass of 0.21 Jupiters? Where is all the gas going? Maybe with a lot smaller stuff. Planet 9. Planet 9's a lot smaller. Let's just launch a bunch of Planet 9s at Jupiter. Okay. So Jupiter's lost a considerable amount of mass, but it managed to net gain 0.03 Jupiters from that initial impact. Good. And now everything has settled. All the gas is collected. Let's try the opposite. Maybe we're doing this too quick. Fire this again. And then maybe, okay, it will go back down again, and now we're at 1.05 Jupiters, and all the gas will slowly come back. All right, so let's speed this up a little bit because we know the gas will come back, and now we're at 1.06. What if we fire a Saturn? See, that's where bad things can happen. And Saturn overtook Jupiter for some reason, but it's still the mass of 2.88 Jupiters. Okay, now we're at 3.18 Jupiters, so that was a little messy, but we can work with it. Got 6 Jupiters. I'm just gonna rapid fire Uranus. I don't care. Uranus seems to be the solution for forming a star. So how to form a star with Uranus? What did I just make? The sound is cut out. We've made this thing. Huh? I've never seen this before. It's at 8,000 Celsius. It looks like a ball of gas that probably shouldn't even exist. Maybe it's even the most bare bones star that you can have, but we've reached a new level of gas giant or star or whatever this is. It's called a fragment. And it's a mass of almost 8 Jupiters. Let's just keep adding to this thing and see how far we can go, even though there's no sounds, and I wish we did have sounds. This thing is translucent, by the way. You can kind of see through this. This is weird. Just keep firing. Okay, is it still going to stay like this? Eventually, this has to turn into a star, right? Now we're at 9 Jupiters. Okay, 9.9 Jupiters, almost 10. I'm pretty sure this is a glitch. This has to be a glitch. But we made a gas ball, so that's cool. Can we fire a normal Jupiter into this now? I mean, this thing is so big. Fire a Saturn. Don't break it. Don't break it. Don't break it. Okay. Firing Saturns into this just works now because it's so big. It can actually collect all of the fragments that result from it. Yeah, now it's 12 Jupiters. All right. We're in business now, firing a bunch of Saturns at this. Don't make too big of an explosion, by the way. Okay. Something just happened. It's reverting. We're at 13 Jupiters, and now it's turning into that big plasma ball. Looks like we can just rapid fire Jupiters now into this thing. Don't even care. Just suck it all up. Ooh, the innuendos. 31 Jupiters. Don't even care. It's so big now that Jupiters can collide into other Jupiters, and it can take everything. Now we're at 40 Jupiters. Okay, let's just go faster. Go faster. We can rapid fire this now. It can take a lot now. 50 Jupiters. Okay, now it's at 44 Jupiters. Okay, a lot of bad stuff is happening, but it's still sucking it all back up to 62 Jupiters. Will you become a star? Become a star, become a star, become a star. Yes! We made a star! By not increasing the mass, now we're at 80 Jupiters, give or take a little bit. I don't know, I was firing a whole lot right there, but according to this game, that's like the minimum mass it takes. Now can we make this thing go supernova? Oh, it just got bigger, 85 Jupiters. Okay, let's going back to gas giant because it was starting to lose some mass because it's, oh no. And now we managed to bring it back into a gas giant because it lost like 20 Jupiters worth of mass. Fire it back in that direction. Get that velocity going. Okay, it's gonna bring it back. It's gonna suck it back up. There we go. Back to star status. Look at those crazy coronas too. It's like an uncontrollable star. Okay, it's getting a little better. 80 Jupiters again. It's getting a little bit brighter. Okay, just there we go. And that just happened again. Oh, back to star. Back to Jupiter. It's back. And I like how we have sound again. That's great. 94 Jupe. Come on. Come on. Just stay in there. Stay in there. Just keep collecting it all. Oh no. Suck it all up. Suck it all up. Come on, guys. You guys are the vacuums. You're the Jupiter vacuums. It looks like it's around 80. Around 80 Jupiters. That is the point where you will get a star. The mass is big enough where it starts like crushing itself, and it starts activating the process known as fusion, where the atoms are actually pressing into themselves. Can we do it again? It's very unstable at this point. It's really weird. It's a really weird point. But anyways, that about does it for me. That's our Jupiter experiment and experimenting with Jupiter's moons that were newly discovered. That was a little update that came. So hope you guys enjoyed this roller coaster of a ride, a video, whatever you want to call it. And I will see you all later. Maybe speed that up a little bit. Who's going to ultimately win this fight here? He's slowly sucking up Venus. Look at all of these craters that are getting created. And that is so loud. Oh my God. That's hilarious. It just keeps rolling. It's like a snowman or BB-8.